Okay, in this video, we're going to talk about multiplying two or more radicals together. Remember, we've talked about the product rule when we have radicals. As long as the radical is the same exact index, we should be able to multiply the radicands, the stuff underneath, together. For example, the square root of 4 times the square root of 5 is really the square root of 20, right? As long as the radicals are the same, we can multiply those insides with their insides. Now, if there's a coefficient, a number on the outside, those can't multiply with numbers on the inside. Only coefficients can multiply with other coefficients. So I always say outsides go with outsides and insides go with insides when we're multiplying. Let's do example number 3. In example number 3, it asks us to multiply. You notice that I have the square root of 3 right next to a parentheses, and inside I have a 6 minus the square root of 3. So what I want to do is make sure that I distribute or multiply the square root of 3 through both terms inside the parenthesis. I see an inside 3 but an outside 6, so I can't multiply those together. I can just keep the 6 on the outside and the 3 on the inside. So the square root of 3 times 6 would really just be 6 times the square root of 3, 6 rad 3. Now I do notice that I have a rad 3 times a rad 3. Because they're the same radical, I can take the square root of 3 times the square root of 3 and really say that I have the square root of 9. So square root of 3 times the square root of 3 is the square root of 9. So I have this, 6 rad 3 minus the square root of 9. But let's see if we can simplify it a little bit more. Isn't there an even square root of 9? Well, the square root of 9 is just 3, so I can really simplify and say that I have 6 rad 3 minus 3. Now be careful not to put the 3's together. Be careful not to put the 6 and the 3 together. Nothing that I have is like terms right now, so it looks like this would just be my final answer, 6 rad 3 minus 3. All right, what if I have cube roots? Like look at B. I have the cube root of x times, and then a couple different terms inside that parenthesis. Let's go ahead and still distribute. And as long as my radicals are the same, they're both cube roots, I should be able to multiply insides with insides. So when I distribute the cube root of x to the cube root of 3x squared, when I multiply x times 3x squared, you should really get 3x cubed. And when I multiply the cube root of x times the cube root of 81x squared, you should get the cube root of 81x cubed. All right, let's see if we can simplify. I noticed underneath my first radical that I have a 3. It's already a prime number, can't be broken down anymore, and if I'm looking for groups of 3 because I have a cube root, I don't have enough 3's to come out. But I do notice that I have 3 x's. If I'm looking for groups of 3, doesn't that mean I can take out one whole group? So I can take out an x, and then I would have that lonely cube root of 3 left over. Let's look at the other radical, 81. What does 81 break down into? Well, it looks like 81 breaks down into, I did 9 and 9, and then I broke down my 9's into a whole bunch of 3's, and I'm looking for groups of 3, so it looks like I can bring out one group with one lonely 3 left inside. I have 3 x's, so I can bring out that whole group with no lonely x's inside. So it looks like the cube root of 81x cubed really breaks down into 3x times the cube root of 3. Ooh, look at that. I have the cube root of 3 here and a cube root of 3 here. Remember when I'm adding or subtracting, if I have the same exact radical with the same exact radicand, I can combine those like terms. That's like having x's and x's or y's and y's. So I should be able to combine those into one cube root of 3 by adding or subtracting their coefficients. So what's 1x minus 3x? Well, I can really say that my final answer is a negative 2x times the cube root of 3. Making sure you distribute by multiplying your insides with your insides, breaking down your radical, and then if your radicals happen to be like terms, combining those like terms. That was a good one. All right, let's do a couple more here. Look at C with me. It looks like C has 2 terms in the first parenthesis and 2 terms in the second parenthesis. I have 2 binomials being multiplied together. We've done this before. Do you remember FOIL? Well, we're going to do the same exact thing, just this time we have radical terms in here. Remember, when I have outsides, outsides multiply with other outsides, but insides only multiply with other insides. Let's go ahead and use our foiling technique to distribute all of this through. I'm going to take 4 rad 5 and multiply it by 2 rad 5. Remember, outsides go with outsides and insides go with insides. So 4 rad 5 times 2 rad 5 should really be 8 rad 25. I'm also going to multiply the 4 rad 5 by the 4 rad 2. If outsides go with outsides and insides go with insides, I should end up getting 16 rad 10. Now let's do negative 3 rad 2 times the 2 rad 5. That gives me negative 6 rad 10. And let's distribute or multiply through the negative 3 rad 2 times the 4 rad 2. That should give me a negative 12 rad 4. So we should have the same terms here. Let's see if we can simplify any of these terms though. I notice that the first one has 8 times the square root of 25. And I know that there's an even square root of 25. It's just 5, right? So really, I have an 8 times 5. Or can I say 40 right there? And in my last term, I have 12 times the square root of 4. And I know the square root of 4 is just 2. So really, I have 12 times 2, or minus 24. All right, look at my middle terms. Don't they both have the square root of 10 in them? Those are like terms, aren't they? So when I'm adding or subtracting, if I have a 16 rad 10 minus a 6 rad 10, I should be able to combine those like terms. When I combine those like terms, 16 rad 10 minus 6 rad 10, I should end up getting 10 rad 10. Then I should be able to take the 40 and the negative 24 and combine those into a 16. So I have a 16 plus a 10 rad 10. None of those are like terms. Make sure you don't combine the 16 and the 10. That would just be our final answer, 16 plus 10 rad 10. All right, let's look at D. I have the square root of A minus the square root of B times the square root of A plus the square root of B. Look at that. I have what we call conjugates, right? They're the same terms, just opposite signs in the middle. Let's see what happens now. Let's do the square root of A times the square root of A. The square root of A times the square root of A is the square root of A squared. The square root of A times the square root of B is the square root of AB. Negative square root of B times the square root of A is the negative square root of AB. And negative square root of B times square root of B is negative square root of B squared. I have two B's underneath, that's a B squared. All right, what do you notice on this one? Well, on this one, I notice I have a positive 1AB, positive 1 square root of AB, and a negative 1 square root of AB. Don't they end up canceling each other out, zeroing each other out? Because 1 minus 1 is 0. Because they're like terms, they have the same exact stuff. I can combine those, and they end up zeroing out. Now look at the square root of A squared minus the square root of B squared. Don't I have two A's underneath here? And if I'm looking for groups of 2, can I bring out that group of A's? Same idea with the B's. Can I bring out the group there? So really I have an A minus a B, so my answer would just be A minus B. All my other radicals that actually ended up going away, my middle terms canceled because I had opposites, and then I was able to reduce my outside terms into just an A minus B. That should always happen when I have conjugates. Remember, if I have the square root of A minus the square root of B and the square root of A plus the square root of B, those are what we call conjugates of each other. We'll talk about that and use conjugates in the next video.